What if space is not a straight line? What if it can be folded, bent, and pierced? This is the simplest metaphor. Two distant points connected by a shortcut through higher dimensions. Einstein and Rosen called it a bridge. We call it a wormhole.
Science fiction. We've seen it 1,000 times. But is it real?
That is the central question, isn't it? Are we observing a phenomenon grounded in established physics, or confronting a hypothesis that still borders on speculation? 1935, Einstein and Nathan Rosen discovered that their equations allowed for something extraordinary: bridges in space-time, shortcuts connecting two distant points.
Wait, that's not a tunnel. That's two black holes connected?
Correct. An Einstein-Rosen bridge is a solution to the field equations that mathematically links two regions of space-time, often associated with black holes. The limitation is stability. The throat undergoes rapid gravitational collapse, preventing any causal signal from traversing it, even photons.
So the solution is mathematically consistent, yet physically non-viable. A space-time configuration that collapses before it can be operational?
Unless you have a way to keep it open. Exotic matter, negative energy, things that push space-time apart instead of pulling it together. Exotic matter, not found in nature, not in any stable form, but quantum mechanics suggests it can exist, briefly, in microscopic amounts.
So wormholes are mathematically possible, but physically impossible. A door that exists only on paper.
For now. But impossible is just a word scientists use when they haven't figured it out yet. And there's another layer to this story. One that involves not just space, but time. Time. We experience it as a river, flowing in one direction, past to future, cause to effect, irreversible.
But if space can be bent, can time be bent too?
Absolutely. Einstein taught us that space and time are the same fabric. If you warp space, you warp time. A wormhole doesn't just connect 2 points in space, it connects 2 points in space-time.
A 1,000 years in an instant.
This is time travel, not through a machine, but through geometry. The ultimate shortcut through the fourth dimension.
But if I go in at one time and come out at another, what happens to the time in between? Do I age? Does the universe age?
From your perspective, the journey is instantaneous. You don't age. But from the universe's perspective, 1,000 years have passed. Everyone you know is gone.
So time travel isn't just about moving through time. It's about leaving your time behind, forever.
This is the price. Time travel is possible. But it's a one-way ticket. You can never go home. Not to the home you knew. This is the tragedy of the time traveler. They gain the universe, but lose their world. But what if the wormhole connects 2 points where time flows differently? What if one end moves faster than the other?
So, the two ends of the same wormhole experience time at different rates.
This is where physics breaks. If you enter the fast end and exit the slow end, you can arrive before you left. Cause and effect reversed. The paradox, the ultimate barrier to time travel. But physicists have proposed solutions. The Novikov self-consistency principle. The many worlds interpretation. Which one is correct? Novikov said, time travel is possible, but you cannot change the past. Whatever you did in the past, you already did. Your actions are part of history. No paradox, just a closed loop.
So if I were to traverse a closed time-like curve, the outcome would be constrained. The initial conditions would enforce consistency. Any attempt to alter the origin event would fail, through deviation, interference, or inevitability. Perhaps my presence in the past was never an anomaly, but an integral part of the space-time history.
But the many worlds interpretation says something else. When you go back, you don't change your timeline. You create a new one. A parallel universe where your grandfather dies. You are never born there, but you still exist in your original timeline.
So, every time travel creates a new universe? Infinite universes branching every moment?
This is the price of the many worlds. You can go back. You can change everything. But you'll never know what happened to the world you left. It continues without you, and you become a stranger in a universe you created. Paradox or multiverse? Closed loops or infinite branches? Physics doesn't have the answer. Not yet.
So wormholes and time travel are possible. But they come with a cost. Loneliness, paradox, infinite universes. Is it worth it?
But to keep a wormhole open, you need exotic matter. Matter with negative energy density. It pushes space-time apart, preventing the throat from collapsing.
Negative energy. The Casimir effect, two metal plates in a vacuum. They attract each other because of negative energy between them.
Exactly. Negative energy is real. It exists, but only in microscopic amounts. Not enough to stabilize a wormhole. Not even close.
So we need a mountain and we have a grain of sand.
But physics evolves. What's impossible today may be engineering tomorrow. Dark energy, for example, is a form of negative energy on a cosmic scale. If we could harness it,
So wormholes are not impossible. They're just beyond us. For now.
a 1,000 years ago, flight was impossible. 100 years ago, space travel was impossible. Today, we dream of wormholes. Tomorrow, our descendants may walk through them.
What's on the other side? Another galaxy? Another time? Another universe?
That uncertainty is the frontier, whether it leads to another region of space-time or simply to deeper understanding. It is the pursuit itself that defines us. We step forward not because we know what lies beyond, but because we need to find out.
So I am free to keep asking, keep exploring, and keep surpassing the edge of my own knowledge.
Let's imagine a civilization advanced enough to harness exotic matter, to build a wormhole, to connect 2 points in space-time.
What does it feel like to travel through a wormhole?
You step out and you're in another world, another time, another possibility.
And the people you left behind? The world you knew?
That's the choice. The universe or your world. The journey or the home. Wormholes give you everything. But they also take everything.
Maybe that's why we haven't found them yet. Maybe the ones who built them chose to stay.
Or perhaps they did not vanish at all. Perhaps they crossed their own threshold and now observe from the far side, asking whether we will ever do the same.
Wormholes, time travel, exotic matter, parallel universes. It's overwhelming.
Science often is, but look at what we've learned. Wormholes are mathematically possible. Time travel is a natural consequence of relativity. The barriers are engineering, not physics.
So it's not a question of if, it's a question of when. When we're advanced enough.
And when that day comes, the universe will become a neighborhood. Distances will collapse. Time will bend to our will. We will become the masters of space-time.
Masters of space-time. It sounds like a dream.
Every great achievement started as a dream, Minto. The key is to never stop dreaming and never stop asking. Perhaps one day, our descendants will look back at us and smile. We were the ones who dreamed. We were the ones who asked the questions. And we were the ones who paved the way.
Thank you, Mr. Kaler, for showing me that the impossible is just the unexplored.
That's what mentors are for, my boy. To light a spark, you carry the flame now.